This video is on the opening exercise from Lesson 23 in the Grade 7 Module 3 book found on page 143. In this one, we are getting into something called volume. And volume, you don't even have to write the definition, they give it to you right in this paragraph. The volume of a solid is a quantity given by the number of unit cubes needed to fill the solid. So unit cubes are cubes that are 1 unit tall, 1 unit wide, and 1 unit long. Kind of like area. Area was measured in squares that were 1 unit wide and 1 unit long. In cubes are three-dimensional, so we also have that tall measurement in there. All right, so most solids, rocks, baseballs, people, cannot be filled with unit cubes or assembled from cubes. It would be pretty gruesome if we tried to assemble people from cubes, but we can measure all these solids because they all still have volume. We don't need to be able to take cubes and put them all together to make these objects. We can measure their volume by taking the dimensions, the length, the width, and the height. So from here, what we're going to do is we're going to look at this diagram here first, talk about the area, something we're all familiar with, and then we're going to turn that into volume eventually. So right here it says, what is the area of the square pictured on the right? Explain. So let's take a look at this. Well, this picture here, we see it's 1, 2, 3, 4, 5, 6 units tall, or long, I should say, 6 units. And it's also 6 units wide. So the area of this is, the area is 36 units squared because there are 36 squares that fill up the entire square. I did some shortcut using multiplication. I did 6 times 6, but you can go ahead, you can count them, and you will find that there are 36 units, or 36 squares that make up this entire large square. So moving on, it says draw a diagonal joining the two given points, then darken the grid lines within the lower triangular region. What is the area of that triangular region? Explain. So let's kind of do what they said to do there. We're going to take a ruler, and I have those red dots on mine, but yours, you do not. Either way, we're just going to draw a diagonal, stretching across it. There's our diagonal. And it wants us to darken, so we're just going to go over these with our pencil real quick. Go ahead and do that. So there we are. That's what I meant by darkening the grid lines. So we have them obviously here dark on the other side. We want to find the area of this triangular region. So to find the area of it, we know that the area of a triangle is equal to 1/2 times the base times the height. The base and the height have to be perpendicular. Right here, I see that that's where my 90-degree angle is. And again, I'll remember from here to here, the base is 6 units. And my height was also 6 units. So when I find the area of this, I can just do A equals 1/2 times the base, which was 6, times the height, which was also 6, and that tells me my area equals 18. So we'll say that the area is 18 units squared, and if we look into it, well, we don't have 18 perfectly whole squares. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 whole squares, containing 15 whole squares, and see these right here are half squares. They were cut in half, We have 1, 2, 3, 4, 5, 6. 6 half squares. It's important to remember that the 6 half squares equals 3 whole squares. If you do take 6 halves and add them all together, you get 3 wholes. So, and that 15 plus 3 will give us our 18 units squared, our 15 whole squares. So we see that, and it's kind of stuff we already knew. Let's connect it into volume now. So now the volume, moving down, says what is the volume of the right prism pictured on the right? Explain. So to help you try to understand what's going on in this diagram, I know I had kind of trouble at first, it's a little bit of an optical illusion. We have cubes. 1, 2, 3, 4, 5, 6 cubes going across and 6 cubes going down. So this is a three-dimensional prism. So when it asks what the volume of the right prism pictured on the right is, what you're doing is you're just counting how many cubes make up this this prism. If you go ahead, you can count them. You count them, you get 36. You could also remember I just said that it is 6 wide by 6 long. So we will write the volume of the prism is 36 units cubed. That's what to the third power means, because it takes 36 unit cubes to fill the prism. So important differences to realize there is now we measure volume in units to the third power. That's because there's 3 dimensions: length, width, and height. Also, please remember that unit cubes are cubes measuring 1 unit high, 1 unit wide, and 1 unit long. So that's what each of these cubes are there. Moving along, let's go down. It says draw the same diagonal on the square base as done above, then darken the grid lines on the lower right triangular prism. What is the volume of that right triangular prism? We have to explain. Well, let's go ahead, let's look at what they're talking about. So they, just like up here, how we drew this diagonal line, they want us to do that, and pretty much what we're doing is cutting all these cubes, splitting this prism apart, splitting it in half. Some of the cubes will be split in half themselves. Let's go ahead and let's do it. So get your ruler and line it up corner to corner, top corners of the prism. Draw your line, and then again you're going to take each, you're going to darken each grid line on the lower half. There we have that. We have the grid lines darkened in. So let's see what they want. They want us to find the volume of the right triangular prism. Well, volume, as we remember, is just how many cubes can fit inside this space. So I could count it. I could count 1 cube, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 holes, 1, 2, 3, 4, 5, 6 halves, which is 3 holes. So we will say on here that the volume of the right triangular prism is 18 units cubed, and that again, the right triangular prism we're talking about was all this right here. Once again, 15 whole cubes, 6 half cubes for 18 whole cubes. Next part down says, how could we create a right triangular prism with 5 times the volume of the right triangular prism pictured to the right without changing the base? Draw your solution diagram, give the volume of the solid, and explain why your solution has 5 times the volume of the triangular prism. So, kind of hard to draw this, especially since I am not good with art at all. So I will just show you an example of what something 5 times the volume of this would be. So kind of our goal though, our goal is to get a, if we're going to get a prism with 5 times the volume of the one we just did, and this again, this right here, This right here is just a different diagram of what we did above with the 18 cube units. We could take this right triangular prism, and instead of just having it be 1 unit tall, we could make it 5 units tall. Let me show you what that would look like. So there we go. You don't have to draw it. I know that is challenging for people with artistic ability. So definitely out of my realm of possibility. But anyway, we could see here, this is the piece we had. Now we're stacking 1, 2, 3, 4, 5 of those bases on top of each other, therefore giving us 5 times the volume of our original. So we will write, if we stack 5 exact copies of the prism on top of each other, we'll have 5 times the volume. And here's just breaking down 5 times 18 units will give us 90 units cubed. All right, down to the next one. What could we do to cut the volume of the right triangular prism pictured on the right in half without changing the base? Draw your solution on the right, give volume to the solid, and explain why your solution has half the volume of the given triangular prism. So what this is asking us to do is to go from our original volume of 18, and now they want only half of that. They want only 9 units cubed. So from 18 units cubed to 9 units cubed. Well, let's kind of look at a visual of that, and I'll put up a visual right now. So there it is. There's kind of the visual, and again, we're kind of cutting this layer in half. So you see right here how we went from this one triangular prism into 2 triangular prisms, but notice how the height of each cube is shorter than the original. That's because in the diagram they took whatever instrument and they cut along that red dotted line there. Well, at least as close to a dotted line as I could do freehand. So to answer this, we will write, if we slice the height of the prism in half, each cube would only be a half cube, and the total volume becomes half of the original. All right, so to sum all this up, to find the volume, which is represented by V, of any prism, determine the area of the base and multiply that by the prism's height. And it's important to remember that this is only for a right prism. Right prisms are when the height is perpendicular to the width or the length, depending on which way you're looking at it. AKA, that means the prism just goes straight up and straight down.